Okay, so parametric equations. Not sure if you guys have seen this before, but basically what parametric equations do, it takes a normal equation and breaks it down to two other equations. So sometimes that'll be advantageous when you're taking physics. Like, for example, if you're looking at like projectile motion, you want to look at the horizontal and vertical motion, be able to break it down into components. That's kind of the advantage of using parametric equations. Kind of gives you a little more freedom to do with what you want. And t is called the parameter. So t is called the parameter. It's actually right there also. Sometimes we use theta. Sometimes theta is used. And this is it's kind of like a control in a way. It's kind of like if you had a slider and like you could say, well, let me switch t to this. How does x and y change according to t? So basically you're writing two equations in terms of t. X in terms of t and y in terms of t. That's all it ever is. So let's take a look at an example. I think that's just kind of the best way to handle it. I can get very theoretical about it, but I think we'll just do an example, right? So these are parametric equations. X equals t squared minus 4, y equals 1/2 t. This came from an equation with just x and y. That's where it came from. And we're going to look into that in just a little bit. And that's called eliminating the parameter. We'll talk about that in part B. So for part A, you're asked to sketch the curve when t is between -2 and 3. Here's how I would do it. I'd make a table of 3 columns. T, x, and y. And clearly I'm going to need more space than that. So let me do it over here, actually. You guys could probably have more space in your paper. Okay, so you want to go from -2 to 3. Personally, I would do it in increments of 1. You can make it finer if you want. I don't think that's necessary. And then you just plug it into each equation and get answers, right? Like, for example, if I plug in -2 into x, what do I get? 0. And if I plug in the y, what do I get? You get -1, right? Yes, keep going. If I plug in -1, I get -3. Plug in -1, I get -1/2. 0, you get -4. And 0. 1, you get back to -3. Actually, let's just do all the x's, get them all out of the way because it's all symmetric, right? And let's get all the y's out of the way. That's going to be 1/2, 1. It's linear, right? 3/2. So the first point you're going to plot is 0, -1. Next point you're going to plot is -3, -1/2. Did I make a mistake? No, please let me know if I made a mistake. Okay. -4 zeros right here. -3 and +1/2. So it's actually not a function. It's kind of interesting, right? It's not a function. 0, 1. So what kind of graph do you think I'm generating here? Yeah, it's sideways parabola. Totally. Now I can plot more points, but they only wanted t between those values. So yeah, it's totally a sideways parabola. Oh, geez. But everyone's here today, right? Yeah, cool. Right. So is y a function of x? No, obviously it's not. Now, I expect this equation to be x equals y squared, something kind of like. And actually, personally, I know it's going to be. I think that's going to be the equation. I'm not 100% sure, but we're going to prove it. How do I do it? Yes, exactly. When you limit the parameter, you're going to do substitution. And personally, I think it'd be easier to get t by itself in the second equation, right? If you get t by itself in the second equation, of course, t equals 2y. And you're going to substitute into the first equation. And you get this, right? At this point, you're kind of okay with leaving your answer like that. I'm okay if you leave your answer that way. It's totally fine. If you wanted to go a little further with it, you could say x equals 4 parentheses y squared minus 1. So that way you can see the vertex at 0, 1, right? Hold on. Does that make sense? No, the vertex would be, wait. Why am I not seeing where the vertex would be? Oh, the 4's got to go to the other side. My bad. Yeah, sorry. Wow, can't believe I did that. X plus 4 equals 4y squared. So it's negative 4 comma 0. My bad. There we go. But you do have to state the domain and range because you're not doing the whole graph, obviously. So it's pretty clear that the highest x value, the lowest x value is negative 4, and the highest is 5. And for y, the lowest y value is negative 1, and the highest is 3/2. There we go. Wait one sec. Yes, yeah, it should be 5. Yeah, 5 is the highest x value, right? Yeah, right. Okay. So that's kind of a crash course in parametric equations. Questions that seem pretty straightforward. We will go deeper with it for sure, but I'm just kind of introducing it. You guys didn't see this last year, right? Yeah, so it's first time anyone's seeing this. Okay, something new. That's good. And again, we will dive deeper with this later in the year. So, okay, let's move on to analyzing functions, increasing, decreasing, constant, all that stuff. Okay. So increasing, what does that really mean? It's a little bit of a tricky concept. Well, here's what I'm going to say. Let me do a text box. The y values increase as x increases, then the function is increasing on that interval. Another way of thinking about this too, if you drew a tangent line and has a positive slope. So let's look at this graph here. Let me get a highlighter out. The graph is increasing at those two intervals because if I drew a tangent line, right? If I drew it, do you guys know what a tangent line is? Yeah, it just grazes the graph, right? At one point. What's the slope of that orange line? Positive, right? So it's increasing, right? Likewise over here, that's also increasing. So that's another way of thinking about it too. That's actually a more calculus way of thinking about it. Another way you can think about it too, if you want to take a more simple approach, it's like a roller coaster, right? You board the roller coaster off to the left, right around negative infinity. As you board the roller coaster, are you going up or down? You're going up, right? And then you hit a peak, right? And then, well, in this case, we stay flat and we keep going up. But usually you go down afterwards. But technically speaking, if the y values increase as x increases, then the function is increasing on that interval. So as you can imagine, decreasing is the opposite, right? So if the y values decrease as x increases, then the function is decreasing on that interval. So in this case, let me get a highlighter out again. This is where decreasing. Now your tangent line will have a negative slope. So if I drew a tangent line right here, what's the slope of that blue line? Negative. So that's another way to think about it. So that's decreasing. So the function is decreasing on an interval. And we're going to state the intervals in just a sec. Actually, we'll see it now. So where are we increasing? We're increasing from negative infinity up to what number? -2. And you actually include the -2. Some people, and just, like on AP Calculus exam, there's some people feel like you should include it. Some people feel you should. They actually are so confused about that. They'll just say, give me an open interval, because they don't want to avoid the confusion. But there's nothing wrong with including it, because it is increasing up to that point. If you didn't include it, I wouldn't fault you for that, because you're not wrong. So there's a bit of a debate. It's kind of ambiguous, like should you or should you not include -2. So on the AP Calculus, AB and BC exams, they sometimes just say, just give me the open interval where it's increasing, or give me the, open interval where it's decreasing. So that's how they will ask it. And of course, there's still more. Where else? From 3 to 5. And in decreasing, clearly it starts decreasing at 5 and forever. And constant, I think, is pretty obvious. Y values don't change, right? As x increases. And likewise as x decreases too.
Why do I always keep saying as x increases? Because usually we like to look at it from left to right. That's the way we should read graphs, from left to right. So like if we're the roller coaster here, so you're on the roller coaster, you're going up, you stay flat, you go up, hit a peak, you go down.
So that's really all there is to it. There's kind of more of a fancy way of expressing, but I don't want to do that. I think just kind of giving a more layman's term that I think might make sense. Any questions on this? Okay. And where's a constant, by the way? Yep, -2 to 3. And again, I'll include it. Okay, and actually I need to get my plug.
If they're both included, it's simultaneously increasing.
I know that's the ambiguity, right? That's where people debate over it. It's kind of, yeah. I wouldn't you drive yourself nuts thinking about it. So don't worry about it. Okay, let's keep moving. Extrema. Now, extrema is a plural for extreme, right? So we have high points, we have low points. And they also have high points that are absolute, like they're the absolute highest or absolute lowest, or they seem high or low for their neighborhood, wherever, little area you're in. For relative minima and extrema, I'm going to make it real easy for you. So for a min, so that's a low point. That's when you switch from decreasing to increasing. It's good to actually have taught AP Calculus, because I know exactly how you have to think of this. It's when you switch from decreasing to increasing, because you have something like this here, you have a dip, right? It's pretty clear that was decreasing beforehand and it's increasing afterwards. It's like the roller coaster. You're going down, now up, right? If you are looking at a more sophisticated way of thinking about this, like, hey, when x1 is less than x2, then clearly we would expect f of a to be lower than any x value in that interval. So f of a would be the relative min, because if this is a right here,
That's a right here, right? So that's a from f of a. And let's say this is x1. Let's say this is x2,
right? It's pretty clear f of a is less than f of x1, f of x2, right? So that's kind of a more formal way of thinking about it. And then it's just reversed. For our local max, it's simply reversed. F of a is greater than or equal to. But really, it just means you switch from increase to decrease. That's really what it means. Okay. Questions? No. Okay, let's keep moving. Okay, so here we're gonna actually do this in the graphing calculator. Actually, if you have a graphing calculator, please get it out. If you need to borrow one, actually, I have a whole bunch on the little ottoman there. If you need to borrow one. But we should actually all do this in the calculator because I want to make sure you guys are comfortable. And I'm gonna make you guys do it on the graphing calculator because I highly doubt the AP exam is gonna be online. Maybe it might be. Who knows? If the AP exam is online in 2025, when you guys do AP Calculus AB or BC, and they have Desmos built, because the digital PSAT, digital SAT is gonna have Desmos built into it. I don't know. But we'll see. But for now, let's just assume.
What
was that?
What are you doing on the PSAT?
I don't know. If you're on the computer, just want to have a calculator to use. I don't know. All right. So let me pull up my calculator too. Oh yeah, it is. Yeah. It's pretty neat, huh? Yeah.
Wow.
Yeah, that's kind of neat. Okay. My algebra 2 students were impressed. I'm glad you guys are impressed. Okay, good. All right. So let's go and graph this. You guys are comfortable graphing? Okay, cool. Yeah, they were not because they had.
You know when the graph in geometry.
No. So, minus 3x squared minus x plus 1. Okay, so we're going to graph that first. And by the way, whenever you graph something, I always like to do the standard window. That's usually a good window to go with. If you have to adjust, we'll adjust. But the standard windows seem to be pretty good for us here. So the graph looks like this. Actually, I'm not going to plot the graph just yet because I do want to get all the features of it first. So I'm not going to do a sketch just yet. So state the intervals where it's increasing and decreasing. Okay. So it's pretty clear. Actually, you know what? I am going to do a sketch. What the heck? The y-intercept is 1. I know that. I think it does something like this. Okay. And it's pretty clear it's going to be increased. Actually, let's do a different color. Let's do blue here. Okay. So it's pretty obvious it's increasing from here to here. Increasing from here to here. Decreasing from there to there. But I do need to find those x coordinates. So how am I going to do that? This is where the graphic calculator will help us tremendously. We're going to go second trace. I'm going to start with maximum. So I want to find the high point. Have you guys found high points, low points square?
Yes.
Okay, so this is all should be review. Okay. So clearly it looks like I'm sitting right at the peak. So I'm going to go a little bit to the left of it, hit enter, and it puts a little arrow up above. Then I hit the right key, go a little bit to the right of the peak, hit enter, puts another arrow up above. It asks for a guess, just hit enter. And it should give me the maximum. So the maximum here is going to be negative 0.15. I know that's what I meant. The coordinates going to be negative 0.154, comma 1.079.
How many of those decimal digits?
I like 3. And the reason I like 3 is just for AP. That's what they want. Yeah, so 3 will be our standard. The low point. Let's find the low point here. You go back, second trace. Now you do option 3. You go a little bit to the left of the low point, a little bit to the right of the low point. Hit enter. I get 2.155 and negative 5.079. Okay. So now when I state the intervals where it's increasing and decreasing, so the answer to actually answer these questions now I can do it. I got all the data I need. Where am I increasing? I'm increasing from, actually, let me just do it like this. I'm increasing from negative infinity up to negative 0.154. bracket, union, bracket, 2.155, comma infinity. Why do I not put brackets around infinity? What is infinity? I don't know, right? You can't reach it. It's an unattainable number, right? It's this abstract idea. Decreasing, you're between two numbers clearly. Negative 0.154 and of course 2.155. Okay, cool. And then when you state where the relative mins and maxes are, it says two decimal places. You know what? That's fine if you do two. I'll specify on a test, don't worry. But I'll just do three in my notes because I'm used to doing three. If you did two, that's fine. The relative max is going to be where you see that change from increase to decrease. So that's negative 0.154, comma 1.079. The relative min, of course, is at negative 5.08, comma, oh, oops, I'm sorry. I'm totally losing my mind here. Thank you, 2.155, negative 5.079. Right, cool, okay. Questions? Good, okay. And why do we call them relative? How come those are not absolute? Okay, well, Aria, go ahead. Yeah.
Yeah, it's not the highest possible point, right? The highest possible point, I don't know, right?
The lowest possible, I also don't know. Relative means just like within the neighborhood, right? But more specifically, it's just when you switch from increase to decrease, relative min, max. Switch from decrease to increase, relative min. And absolute mins and maxes also have the title relative. They just have another title. They're also absolute too. Okay, let's keep on moving. All right, so during a 24-hour period, the temperature of a certain city can be approximated by the following equation. Your domain's from 0 to 24, so T is the time of day. T equals 0 corresponds to 6 a.m. Okay. Graph the function you calculate and use it to approximate the maximum temperature during this 24-hour period. So why don't you guys go and try it on your own? And tell me what you guys got. And it's pretty clear when T is 0, your temperature is at 34. Oh, just go, you can go borrow one over there. Oh, buttons. Oh,
I tried turning it.
usually there's a reset button.
Really?
Yeah, I think right here.
Let's grab another one for now.
Yeah, you might need to get a screwdriver and do this at home.
Okay.
Yeah, sorry. Oh, sorry. Over there, that bucket. Yeah, this will be T. This will be Y. And T is hours. Here we go. Since 6 a.m. And Y is temperature in degrees Fahrenheit. I believe the graph looks kind of like this. It's kind of wavy. But you're only going up to 24. Yeah, yes. So it's pretty clear you want X to be from 0 to 24, right? I think it's pretty obvious. The temperature, because now this is where you have to use context, right? You're doing temperature, right? Like, would it make sense to do temperature at negative 100? But maybe you could go down to 0 degrees. You know, some places do get that cold. The high point, would it make sense to go up to 200 degrees? No, maybe 100 or maybe 80. I don't know. Maybe it's winter time. That's a sample window you can use. Anyone get a high point? What do you guys got? Good. So what's the x coordinate? Good. Yeah, this is what my notes say. Yeah. Oh.
Is that how you want us to notate it?
Yeah. Yeah. So that's where the high point occurs. So now if you think about it, that's 6 a.m. plus another 6.602 hours. That's just a notation thing. I mean, if you do that, I don't care. So 6 a.m. plus 6.602 hours. If you think about it, that'll be 12 p.m. plus some minutes. How would I figure that out?
Times 6.
Yeah, times 60, right? Which I think I have in my notes as about roughly 36. So 12, so be about 12:36 p.m. That's when you hit the high point. Okay. So just some context there with the stuff. And again, you're using the second trace, select maximum, go in between, go to the left of the high point, go to the right of the high point. The calculator kind of whittles this way in between and finds high point, right? That's the algorithm it uses. Okay, we're okay with that? Good. Now what time we finish today?
35.
Oh, we got plenty of time. This is great. Awesome. Okay, good. Hold on.
45 minutes before.
Guys, 30, you're right, 35. Yeah, pretty good. Just a rough estimate is fine. Yeah. Okay, anyway, let's keep moving, guys. Okay, greatest integer function. Have you guys heard about the greatest integer function? Is this new? Okay, it's new. It's pretty simple. It's a weird type of function. You see a function with a bracket around it. Some people don't know what that means. What it means that whatever's in the inside, you want the greatest integer less than or equal to that number. So, for example, if I have 3.5, right? What's the greatest integer that's less than 3.5?
Yeah.
It's 3, right? You guys have that. Yeah, it's basically an extension of a piecewise function. That's really what it is. So if you think about it, whatever's on the inside, there's a whole bunch of integers less than 3.5. Right? There's a gazillion integers less than 3.5, but you want the greatest of them all. The greatest of them all is, of course, 3. If I did 3.999, it's still 3, right? But once I hit 4, now it's 4. Because the greatest integer is less than or equal to the input. So this is pretty easy. That's 2, 1. Careful with the negatives. -5, -3, and 0. So that should be pretty straightforward.
Yep.
Questions so far? Not exactly. Question? No? We good? Okay. So let's actually graph this. Yes, yeah, go ahead, yes. No, you want the greatest integer that's less than the input. That's less than the input. I know, it's always a little confusing with negatives. All right. So now we're actually going to draw the graph and then state the domain and range, all this fun stuff. So I'll make a little table if that helps. Like, for example, if I plug in 0, I get 0. What if I plug in 0.9? What do I get?
0.
Still 0, right? But 1, then I get 1. So here's how you're going to do it. You're going to do a closed circle at 0, open circle here, and a dot there. And you keep repeating that. Yes, or a step function.
We did this like one time.
Okay, wow,
Yeah,
okay.
it was not explained to me. We learned as a piece of.
Yeah, it was like.
Yeah, it's called a step function for obvious reasons. You can call it a stair function if you want.
Oh, you didn't go on.
Notice I have holes at certain places because there's a jump, right?
When I get to one, it jumps, right?
0.9999999 it's still 0. 1.9999999 is still 1. Then when you hit 2, jump. 3, jump. 4, jump, and so forth. And it happens over here as well. Yeah, like Van Halen jump. There we go. Okay. One of the things from these. All right. Domain is all real. Still all real. For negative infinity to infinity. There's no restrictions. But the range is restricted. And you can't really write it as an interval. So you're just gonna just use words. What would you say instead of what? Totally, right. X intercepts. It's anything in the interval from 0 to 1. 0, 0 is an X, but also is 0.1, 0.2, 0.3.
Can we do like the brackets 0 and parentheses?
Any X value in the interval.
You know, take that, it's like bracket 0, comma 1.
Yep. And the y-intercept's pretty obvious is 0, 0. Yeah, because 0 is included, right? Okay, so now you're familiar with how that looks. You want to, not be confused, like what is it and why it works the way it does. Now you do. Looks like you've seen it before, but now you have a better understanding of it. So, okay, great. This is incredible timing. Okay, so we'll do the homework quiz. When you're done with the homework quiz, bring it up. You still have some time to get head start on homework. You guys have the homework packets. I gave that to you guys last week. And the homework, just is that worksheet. Let me stop my recording.